In this video, we will be looking at topic 4 of A-Level Maths, and that is polynomials. As always, these notes will be available to buy on my website, which is linked in the description, once I have completed them all. Here are a list of the subtopics we're going to be covering in this video, so let's get into the first subtopic, 4.1. The first subtopic is what is a polynomial. The word polynomial might be new to some of you that are coming from GCSE, but you definitely know what a polynomial is once I explain it. The fancy way to put it is a polynomial is a function made up of sum of terms containing non-negative integer powers of an unknown value. All this means is that it's some kind of equation that might be x cubed plus 3x squared plus 2x plus 7. So it's the sum of those terms, and the powers on the x's or any letter, depending on what it is, have to be positive integers. The way we classify a polynomial depends on the highest power of the unknown term, which in most cases is x. So, for example, a quadratic that a lot of you would have seen before, x squared plus 2x plus 6, will be a degree 2, because the highest term has a power of 2. And as you can see at the bottom, some examples that we have, 3x cubed plus 2x squared plus 4x, 6x to the 7 minus 3x to the 5 plus x plus 7, and then also that one at the bottom. So let's look at question number 1. What is the degree of the following polynomials? Y equals 2x plus 7. The highest power on the x term is 1, so the answer is simply going to be 1. Likewise with b, we've got 3x to the 4 plus 8x squared plus 3. The degree is going to be 4, because 4 is the highest power on the x. And pause and give it a go for yourself. The last question is going to be a degree 3 because of that cubed term there at the start. These polynomials may not always be in descending order of the power, so don't always assume that it's just the first term that tells you the degree. What is the name of the following polynomials? So y equals 2x plus 7, we have the same ones as before. The first one is just a linear polynomial. The second one, because it has power 4, we call that a quartic. And then c is again the same one as above, but that would be a cubic because it is power 3. It is good to know up to power of 5, which is a quintic, just in case. It's very rare that you will get asked something on a quintic, but definitely up to a quartic you may get asked about. Moving on to 4.2, which is polynomial division. This one is probably new to most of you, unless you did a bit of GCSE further maths, but that's not a problem. This is a very useful topic. Polynomial division does exactly what it says. It provides a method to divide two polynomials. There are many uses for this, one being able to aid in factorising larger polynomials. So up to now, a lot of you will only be able to factorise quadratics. Here is the method on the left-hand side if you want to pause it and read it, but I will show you in an example in question number 1. So given x minus 2 is a factor, factorise x cubed minus 2x squared minus x plus 2. So what we want to do is set it up as a bus stop, just like normal division. So we do x cubed minus 2x squared minus x plus 2. We put that under the bus stop and we put an x minus 2 on the outside. So the first thing we need to do is divide x cubed by x, which is the first term here divided by the first term there. Now that is going to give you an x squared, so that is what we put at the top. Underneath, we can now multiply x squared by both of the terms, x and minus 2. That is going to give us x cubed and also minus 2x squared. Once we complete the line, which is essentially what we've done now, we can't do any more multiplying. We draw a line and we subtract the terms. Now the whole point of the initial division to get the x squared is because when we subtract these two, you want it to be 0, which it is in this case. Next we have minus 2x squared minus minus 2x squared, which is actually also a 0. This might not always happen, but it's very good to understand what to do in this situation. Treat it as completely normal, that is fine. So, because both of these are 0, we bring down the final two terms, minus x and plus 2, and we repeat the process again. So we divide minus x by x, and that is going to give us a minus 1, and then we multiply the minus 1 by the x and by the minus 2. And that is actually going to give us exactly minus x and plus 2. Take both of those away and both of those are 0. This is actually really good because if we get a 0 at the bottom, it proves that the x minus 2 is a factor because there is no remainder left over by dividing them. So what this means is we can write this polynomial as x minus 2 and then the remaining quadratic as it is left on the top next to it. And feel free to try and expand those two brackets because they will get you back to that cubic, assuming you've done it right. Now this is not fully factorized. Let me know down below if you do spot this because it's a really good thing to look out for. But this quadratic here is actually the difference of two squares. So you can make it an x plus 1 and an x minus 1. Now that is fully factorized. And that is essentially how we factorize a cubic when it comes to A-level maths. It does help if you are told one of the factors, and in most cases you are. In some cases you may have to use the factor theorem, but that is something we cover in one of the next subtopics, so make sure you hang around for that. Moving on to question number 2. Exactly the same question with different polynomials in a slightly different format, just so that you can see it. So we do the same thing again, and this one will be good because in the last one we skipped over a few steps because these cancelled out immediately. So hopefully in this one we don't see that. So we divide the 2, you get x squared on top, and by divide the 2 I mean those two. And then we multiply down, so x cubed, that first term should always cancel out, so if you haven't done that, double check. And then we get a minus 3x squared. Now, when we try and subtract those two, you will notice that we're trying to do, in this column, a minus 4x, take away a minus 3x squared. Because you can't really combine those two, what we actually need to do here is extend this out a bit and put a 0 in there. So that's a really good tip to remember. Make sure you always have consecutive decreasing powers of x when you're doing this. So the x cubed, the x squared, the singular x, and the constant. Because if you don't, the subtraction can get quite tricky and you can mess up and make mistakes. So going back to this, take those away, we get 0 and we get 3x squared. And then once we have that, we subtract the other two down. And we repeat that process again. 3x squared divided by x is going to be a plus 3x. So if we multiply those across down there and write them below, we're going to get 3x squared and then a minus 9x. Draw our subtract line in, take them away, 0, minus 4 minus 9 is a positive 5, minus 15. And then the final time is going to be a positive 5 because then when we multiply those, we're actually going to get a 5x and a minus 15. And once we take away those two, they are exactly the same. We get a 0 remainder, so that is definitely a factor. And so our final answer here, because we're not being asked to specifically factorize it, is just x squared plus 3x plus 5, which is whatever is left on this top of the bus stop here. Obviously from there you could go down to factorize it. If it factorizes, this one does look like it might not be able to, but that is the final answer for question number 2. Moving on to 4.3, as I said before, the factor theorem. This is very, very simple. It is something completely new to A-Level. You would not have seen this at GCSE. And as I hinted at previously, it provides a way to find the first factor of that polynomial. So if you do have a cubic or a quartic and you're not given the first factor, you can try and find it using this method. The factor theorem typically states, if we're looking as a mathematical statement, if f of a equals 0, then x minus a is a factor of f of x. You'll find a lot of these definitions and statements and theorems sound very complicated. It basically means if you substitute a number into the function, the polynomial, if that equals 0, then that number is effectively a root of that polynomial, of that equation. So I'll show you with some examples because that's always the easiest thing to do. Question 1, is x plus 1 a factor of that polynomial? So using our factor theorem that you can see at the top of the screen, the bracket x plus 1 is related to that x minus a bracket in the theorem itself. So what this means is the a value here is equal to minus 1. Because if we were to kind of solve a quadratic and you had, say, x plus 1, x plus 2 equals 0, the roots of those equations would be x equals minus 1, x equals minus 2, as you would have seen at GCSE. This is exactly the same kind of idea. That's the only reason I've taken the opposite sign, the negative in this case. So we're going to let the a value be -1, and we're going to substitute the a into the x values of this polynomial. So f of -1, when f of x equals this equation, is -1 cubed plus 2 lots of -1 squared, -5 times -1, -6. So if we work out each of those terms, this is what I get. And then if we simplify that even further, you will find that that does actually cancel out to 0. And then it's always good to finish off something like this with a little proving statement or a conclusive statement, just to determine what your outcome is. So we've just said that f of -1 equals 0, so therefore x plus 1 is a factor. Let's use this on something slightly harder in question 2. F of x equals x cubed plus ax squared plus bx plus 60 has factors x minus 5 and x minus 3. So in this case, we know that x minus 5 and x minus 3 are already factors. So the factor theorem is already true for this. So we can say that f of 5 and f of 3 both equal 0 already. So if we substitute the 5 and the 3 into f of x, we can create an equation that equals 0 that is completely made up of only a and b as the unknown variables. So let's do exactly that. So equation number 1 is going to be our 5, and then equation number 2 is going to be our 3. So f of 5 in this case is going to be 5 cubed plus a lots of 5 squared plus b lots of 5 plus 60. So again, just trying to make this as simple as I can so you guys can follow it. I'm just substituting in each of the values, so 5 into the x values in the original equation. And we know this equals 0, so we can rewrite this as 125 plus 25a plus 5b plus 60 equals 0. And then we can rearrange this to actually make it a simultaneous equation in terms of a and b. So I'm going to do exactly the same thing for 3 and show you the final result that I have. Please pause and try this for yourself to make sure you get the same thing. That is the best way you will learn this topic. So here are the two simultaneous equations that I have. 25a plus 5b equals minus 185. And then the second one, 9a plus 3b equals minus 87. Your calculators, if you have one of the A-level calculators, will be able to solve these. So feel free to just put the constants in if you want to. But obviously we know how to solve a simultaneous equation from the stuff we used to learn at GCSE. So let's go ahead and do that. So if we compare the b coefficient here, we can multiply the first equation by 3 and the second equation by 5 to get both of the b's to 15b. So this is what that looks like. And if we take those away from each other, because both the 15b's are positive, they will cancel out. And that leaves us with 30a equals minus 120. And then we can divide by 30 so that a is minus 4. And then if we take the minus 4, sub it back into the second equation, we can also work out what b is as well. So by subbing that minus 4 in where a is, we get 3b equals minus 51, and therefore b is minus 17. And that is your final answer. Just a note, even though you can do this in your calculator, I would always recommend writing down the workings out in your exams, because if you type the wrong thing into your calculator and it gave you the wrong answer, you may not be able to get any credit. Whereas at least if you've got the workings, they can see that you tried to do the right thing. So that is your final answer, and that is the end of 4.3. Moving on to 4.4, and that is sketching polynomial functions. And this is actually the final subtopic, so hang around because this one is also really important, as a lot of it will be quite new. When sketching polynomials, there are a few steps you need to enable you to sketch an accurate graph. So we need to identify the order of the polynomial, which is what we did back in 4.1, so that's really important. Decide whether it's a positive or negative version of that graph, and as you can see I've got some examples down at the bottom of the page. We need to find the y-intercept and also the roots, so that is exactly the same as a quadratic equation that we would have drawn at GCSE. And as a useful tip, the order of the polynomial, so say it's order 3, that will be the maximum number of x-intercepts or real roots that you can have. So if you've got a cubic equation, and your graph crosses the x-axis more than 3 times, you've done something wrong. So that is always a very useful idea to bear in mind when you're doing exams. So let's have a look at question 1. Sketch the graph of f of x equals 2x cubed minus 5x squared plus x plus 2 given that x minus 2 is a factor. Straight away, we've got that polynomial division and factor theorem idea with the x minus 2, so that will be a great start. Before we go straight into the workings out, I think it would be really good to have a checklist. So we should record the roots, the y-intercept, is it positive or negative, and the order. With those 4 things, you cannot go wrong when it comes to drawing the actual graph itself. So the order already we know is 3, because this is a cubic equation, and that is the highest power on the x terms. Is it positive or negative? That cubic term, the 2x cubed, is a positive term, so this will be a positive cubic. So this enables us to know that it is a normal positive cubic shaped graph, that kind of positive S shape that you should all know. And actually the y-intercept is just f of 0, which, just like a quadratic and a linear equation as well, is that plus c, that constant term on the end. Assuming that is the only term that doesn't have an x, plus 2 is going to be the answer every time here. So when it comes to finding the roots, that's actually the only thing we need to work out now. So this is really good. So now will be a good time to go ahead and do the polynomial division as we discussed in the previous slide. So we put the cubic under the bus stop and we put the x minus 2 outside the bus stop and we do our division. So we divide the first two, and that's going to give us 2x squared, which means when we times them, we're going to get 2x cubed, and we're also going to get a minus 4x squared. We can go ahead and subtract those. They're going to cancel out the first term. That's exactly what we want. And then we've got minus 5x squared minus 4x squared, which is going to be a minus x squared in there. We can then bring the final 2 terms down. So we just literally bring those down from there. And we repeat. So that's going to give us a minus x next if we do minus x squared divided by the x over here. If you don't like the idea of the division, you can just work out what you need to multiply there to get to there. And obviously in this case, that is that minus x. If we multiply the minus x into both of these two, we're going to get a minus x squared, and we're also going to get a positive 2x. The first term is going to cancel as always, and then we've got a plus x minus a 2x, which is going to be a minus x. And then we bring the plus 2 down again, and we repeat one more time, which actually gives us a minus 1 in there. And that is going to give us the 0. Again, because we already know it's a factor, we know it should equal 0. So if you do get an answer other than 0 when you do this, go back, double check. Worst case, just completely start again, because sometimes it can be quite tricky to see that same mistake. So that means that we can now rewrite this polynomial as x minus 2 and then 2x squared minus x minus 1. Now, because it's a quadratic in the right-hand bracket, we can factorize this, or hopefully factorize it, assuming it is factorizable. We can actually rewrite this as x minus 2. We know the second bracket is going to start with a 2x, and the third bracket is going to start with an x. So we need to find 2 numbers that multiply to make the minus 1, and add to make the minus x, or minus 1, bearing in mind that we've got that 2 at the front. So we're actually going to have a minus 1 and a plus 1 in that order. And if we set that equal to 0, our roots are going to be 2 minus a half. Those are our 3 roots we can use for this. And now we have all the information we need to sketch this polynomial graph. So if I shift our workings to the side slightly and draw a nice big axis. Never try and make your axes too small, because it will make your life really difficult when it comes to labeling especially. But with our roots of 2, 1, minus a half, roughly drawn to scale, it doesn't matter too much. And we can have our y-intercept at 2. We know it's going to be a positive cubic, which conveniently is drawn down here that we can look at to use. I would really recommend kind of having a table when it comes to doing your revision notes of the positive quadratic, the negative quadratic, and the same for the cubic, quartic, and just understand how they change as they go up the powers. So even a quintic looks the same as the W on the quartic, but with an extra downslope. And you'll see they just go more like a kind of cosine sine graph the bigger the powers get, typically. So we can label on there the 2, the minus a half, the 1, and the 2. And then we can draw that S shape. You can kind of see how that is going to work. And that is exactly what our final graph will look like. Let me know if you can draw a better cubic than that, because that is not the best. but they're not really going to be looking for it. As long as you draw it curved and not jaggedy dot to dot, and you've got the clearly labelled points on there, it could be better practice to actually label them as coordinates, but if you just label the numbers, I'm sure that will be okay. And that sums up the end of topic 4, the polynomials topic. Thank you very much for watching. Please like and subscribe if you found it useful, and remember to check out these notes on my website once I've completed all these videos. Thank you again, and I will see you in the next one.